is sending a predictable message. I think just one really, the cipher mode complete. And as I said, it's hard to intercept because it's coming from the phone, but still, the phones too should apply this software patch so that there's no predictability in GSM anymore. And then the crackers would have a much harder time exploiting the cryptographic weaknesses, right? As a wrap-up or a prediction into the future a little bit, I think this is the start of something, not the end. For us, it's the end of a year-long research project. We have achieved everything we wanted. We've shown that this can be cracked, and now we'll give it to the community. For you, it's a start to now be testing your GSM service as much as you're testing a Wi-Fi network before connecting to it. Hopefully you're doing this. You are looking whether you're using web or WPA encryption. You're looking whether the key is predictable, all these things. Start doing that for GSM too, and make sure you control them, that they do install the software patches that are overdue for 2 years. Now, besides our project, of course, there's plenty others that have been kicked off in the GSM space over the last months and years. People are now able to emulate or operate entire base stations, one of which will be used as an IMSI catcher demonstration at DEF CON. We are able to do basically the same, the full emulation and operation on the phone side, which has already led to some interesting results. What happens when you fast test a critical infrastructure? Of course, these have never been fast tested during production, and there has never been a tool, an access path into these networks. Now you have it. Download this, install it on a $20 Motorola phone you get on eBay, and start changing random things. Chances are you will be crashing some critical infrastructure. Now, so don't do it unless you're operating the base station yourself, of course. Now, there's some other interesting works going on in the GSM space. For instance, privacy intrusive attacks. GSM as an ecosystem shares a lot of data across the whole world with every telco out there for roaming, for billing, all these things. Some of that data is exposed to the internet and can be used to perhaps track every single one of you. I'm not going to get into this because the talk following this talk, I think even in this room, we'll be discussing this topic. So there's lots of GSM research kicking off, and it looks like the rate is accelerating. So join in and start your own GSM project. We have a couple minutes left, I think. Let me just point you to the people I want to thank here that have all contributed majorly over this past year to improving AirProbe as much as building this cracker. And of course, thanks to NLnet, who funded this work into a GSM debugging tool. So thanks to all of these people. And I think we'll have plenty of time for a couple of questions now. Thank you very much. Oh, this is the URL to find all the links to the Gits and SVNs and all that, the srlabs.de. Should be the first article on the site. Could you come? Is there a microphone for the questions? There isn't? Okay, just shout. Go ahead.
Do the various different GSM frequencies have any impact on the signal strength of the caller to be able to capture that part of the conversation?
Does what have an influence?
The various different GSM frequencies. You know, there's the
Oh.
frequency, which is, I think, the worldwide one, and then there's others that are more used to the US.
Right. So the question is whether it makes a difference on intercepting a call, whether it's on what the 900 megahertz band or what the 1800 megahertz band. I think the 900 megahertz band has better propagation characteristics. However, once the phone notices that it has better propagation, of course, it's going to tune down its sending power. So it should level out all the same, right? One topic we didn't touch on at all is 3G, of course. 3G, the holy grail of security for cell phones. Now, 3G is great. It is mutual authentication. It has a better encryption function. However, there isn't really a 3G only phone. Every 3G phone is also a 2G phone. And it automatically often falls back into 2G or can be forced that way. By just jamming the 3G frequencies, you make sure that your victim is talking over 2G. Right? So as long as 2G isn't going away, it's still the weakest link of the system. Now, 3G was never meant as a replacement for GSM. 4G will be. So 4G can replace both 2G and 3G, and then it'll be all good, well encrypted, patent-free, and so forth. But that's 5 to 10 years out. Go ahead. Data uses a different suite of encryption functions called GEA 1 and 2. They have not yet been disclosed. Let me just say so much. Go ahead. Could you say this louder? Sorry. Can SMS also be cracked? Yes and no. It just depends on your phone and your network operator's settings. To an old phone, SMS will be delivered through GSM. To newer phones, sometimes they will be pushed over GPRS, which is what nobody knows how well it's secured yet. Go ahead.
Is there a way to test our networks without downloading 2 terabytes worth of data?
If you're serious about it, you can just send me the packets you extract, and I'll help you extract the keys. Sure, yeah. Most of this, though, the predictability, for instance, you can already test without cracking anything, right? So all the packets that were sent non-encrypted, these in the beginning, they too have the filling pattern. So given a USRP, suck down some beacon channels data, run the airprobe tool on it, and either there's all these 2Bs running across or there aren't, right? That's the first strong indication whether they have done anything about it or not. Sure. In the back? Sure, yeah. So the question is, what's to be gained by combining distinguished points with rainbow tables? Well, they're both cornerstones of a design space. The distinguished point tables will lead to tables with 0 collisions. However, as you keep adding chains, you will notice that the same chains already exist in your system and you keep throwing them away. So distinguished point tables can only grow to a certain point. Rainbow tables, on the other hand, can grow much, much larger. However, they're much more costly in the cracking time, because you can't just start in the middle of a stream and compute to the end. You have to compute each color individually, and in fact, the cost scales exponentially with the number of colors. So, oh, good, I have an empty slide here. If you have just one color, you're computing this much. If you have 2 colors, you're computing this much and this much, 3 times as much. If you have 3 colors, you're computing 6 times as much, and so forth. So the cost of cracking grows exponentially with the number of colors, which is why you want to keep the number of colors limited. And this is exactly where the two meet. Rainbow tables is going to become extremely costly if you apply it till the end. Distinguished points, well, extremely costly in terms of cracking time. Distinguished point tables will be extremely costly in generation time. And if you want to keep both limited, you'll meet in the middle. Now there's an Excel sheet. I don't know. Did you guys get the white paper I wrote for this? It's like speaking notes. I'm linking to an Excel there. I should also link on the web page. The Excel has a huge model how to tweak the parameters, and if you change the key size, how much distinguished points and how much rainbow tables you should be using and all of that. Right. Cool. Any more questions? Oh, none really. Well, you need more than a computer just to record those airwaves. But you don't really need anything specialized. This is a very standard tool you'll find in most university labs. And this is just one example of a tool you can be using. It's a programmable radio, right? It's extendable both through software as well as hardware. You stick modules in. And in fact, if I can make a recommendation, for GSM, I would not be using the module it comes with, but rather another module. I think I am naming that on the slide, called the Bergs module. Where do I have that? Which is much more sensitive to the frequencies. We're trying to work on. So this board, in addition to the USRP, is a great starter setup to do really anything to GSM. Right? I think it's $1,000, the USRP, and then this board is maybe $750. Right? You need a second one if you want to do upstream and downstream. Yeah, but still, cheap. If you recall that the commercial crackers cost upwards of $500,000. Yeah. Any more questions? How do I narrow down to a specific phone call? Well, I'm recording exactly from when I press dial till only when I'm done, and I keep it very short. And if I do notice that I recorded 2 calls, I'm throwing the data away. It is difficult, yeah. You're stumbling across all this data you could be cracking, but you aren't legally allowed to. Oh, how do you identify the needle in the haystack? Yeah, that's a good question too. So the phones are addressed by an identifier called the IMSI. It stays the same across the lifetime of the SIM card. So it identifies the subscriber. However, the network will assign another identifier to an IMSI as soon as it connects to the network. So either you get lucky and you see this assignment, then you know the relation, or you do something like you're sending a silent text message to your victim. That way you see what TIMSI receives the text message, and you'll be narrowing down your efforts on that TIMSI, right? But yeah, especially in a city like Berlin, it was hard to not stumble across anybody else's data. There's so much going on these frequencies. Yeah, any more questions? My phone cannot. Cheryl, do you know how to make this 3G only? It says 2G or 3G or 2G only.